This is so awkward. Alright, so my name is Uzman Mohammed. I work here at the Peer and Academic Resource Center, and I am a math tutor. Today, we're working on Math 45, which is DE, and I'm here with mi amigo. Hector, you want to say hi?
What's up? I'm Hector.
Okay, so Hector's working on DE, and we've worked on a couple of the. So you have a test Friday.
Tomorrow. Yeah.
Tomorrow.
Tomorrow.
Okay, so Thursday. So he has a test Thursday, and we're working on some of the earlier problems. So we're gonna try a couple of those on the board, and then we're gonna work on something harder.
Sounds good.
That's really about it. Okay, we flipped the camera now, and we pulled up a variance of some of the problems that we were working on earlier, and Hector's gonna attempt this one on the board. So y prime, or y double prime plus 16y plus 64y is equal to 0. Okay, cool. Let's go to the board. Yeah, you take that with you. Or I can just read it to you.
Oh,
Okay.
It's so hard to write. I don't know what do I do.
Alright, so y double prime
This is so sweet. You're like I do all these things.
plus 16y
I feel like I don't know. Some people have like they do.
plus 64
I don't know. I just feel like
y is equal to 0.
to me it's like maybe I don't do it.
We're solving this, right?
And we are solving this.
Okay. So what I'm seeing is this is a homogeneous equal to 0, so we can use an auxiliary equation.
So in my free time, I won't.
Let's see, 16m plus 64 equals 0.
Okay, so now what does that look like?
That just looks like a regular quadratic polynomial.
Okay.
Find the roots.
So can we factor it, or do we have to use quadratic formula?
Tutoring.
By the looks of it, we can factor it.
Okay, so try.
So this is m plus 8, and then another m plus 8.
So now for all that, just to make sure that's right. Just double check.
Okay, so if we plug that in, we get m squared back to that. Plus 8m, 8m, that's 16m, 8 is 64. That checks.
Okay, same thing. All right, cool. So those are the factors.
Now we can say that m is equal to negative 8,
Okay.
and then because there are two negative 8s, essentially, I think that's
Mhm.
how it's described, this becomes a double root.
Yeah.
Okay, and if I remember correctly, when we have double roots in our solution, we're supposed to have something of the sort. It was like y equals c1 e to the negative 8x, and then the second part was a c2.
And now this is a double. So what happens now?
If we look back, it might have been, there's a x here, I think, multiplied by the same thing as that.
And that's because of the double.
Yeah, that's because this is a double root.
Yep. That's perfect.
And
And then is there a yp after that?
then, no,
Why?
because this is equal to 0.
Yep.
So this is our final general solution
Yep.
for this particular.
Yep. Looks good. Okay. So that's one of them. Okay. So that says, let's see, that says y is equal to c1 e to the negative 8x plus c2 x e to the negative 8x. And then let's see if that's right.
Yeah, negative 8x. Okay. There you go.
And that's right. All right, perfect. Okay, so now let's move on to a couple of the harder ones because we've practiced a couple of these before.
Okay, I might have pulled it up here.
Okay, so this is slightly different. This is now you need to solve the particular because that's not equal to 0, right?
Yeah.
Okay.
I see that.
So let's get that one on the board and let's try that one.
Okay. So just like the previous one, the first step we have to do is act like this is equal to 0 for just a moment.
Okay.
So we can use the auxiliary equation m squared plus 10m plus 25 equals to 0. We'll get back to that. So just like the previous one, we can just get the roots out of this. And this looks to me like it's just the m plus 5, m plus 5.
Yep, that was good.
So our roots are -5, and just like the last one, it is a double.
Okay.
So our general solution called y of c would be c1 e to the negative 5x plus c2 and then double root, so we multiply it by x, negative e to the 5x, and then because of this particular solution here, we need a particular y here as well.
Okay, so we need to solve for yp. So how do we do that?
See how this is not caps.
How do we do that?
We want to keep consistent.
So this, you're supposed to solve this using constant coefficients. Do you remember that from class?
That's all. So
More or less, I think something with like a and e.
Yeah.
Like that. Yeah.
So your yp, you in class you covered a bunch of variants of like different solutions, and so you have 10x plus 7. Do you remember the a and b that goes with that? All the coefficients. Sometimes it's more than a and b, and it keeps going depending on what's attached there. But for this one, you have something that kind of resembles a line. Do you remember what goes with a line?
in literature,
Yes, it's mx plus b, and I think I remember now.
Defining writing
The I don't know what it's called, but the associated, I guess would be ax plus b.
Yep.
Okay, that was okay.
Okay.
And then, so this is our y of p. Let me just. So we're up to the second derivative here, so we need to derive this formula. We get
I want to.
a
You could put this where I'm a
and then
linguistics person.
0 here.
So b goes away because it's a
Constant. This
Constant?
is a constant. This
And
has
then-
an x term in it.
yeah. So derivative of x is equal to
Another or a constant.
yeah.
And then
Well, wait. What's the derivative of x?
oh, the derivative is x 1.
1.
Yeah,
So
sorry.
all you're left with is
Is the a.
yeah.
Yeah.
And then the derivative of a.
Constant is 0.
Okay, cool. So now we have all the derivatives of yp. So now what do we do with that?
We can plug these values or this back into here.
Yeah.
And set it equal to that.
Okay, so let's do that.
Let's just do it up here. So the y prime, well, let's start with y double prime. That's just 0. Correlates with that. And then this 10y prime, we have a plus a 10 a. And then for here we have this ax plus b plus this 24 times the 25 in front of it.
Mm-hmm.
So 25ax plus 25b after distributing, and that equals this particular.
Okay.
Students with a comma after.
So
That's underneath.
so now we have stuff with x's and we have stuff with a's. So we want that to equal 10x plus 7. So
Okay.
do you remember how to organize it?
I think we get the x terms, we set the x terms equal to the x term here.
Yep.
And then the constant terms equal to the constant.
Perfect. So
This is all bolded.
do
You
that.
do that earlier.
Equals 10. And then for this one, we need an a that will get us to that.
yeah.
I guess we just divide by 25 first.
Wide variety of
So
methods.
if a of x equals, or we can just divide by 25x, sorry.
Yeah.
And then we're left with,
Component of physical education. Gathering evidence.
this becomes
Achievement. This can also be done. Okay.
having 2, yeah. So 2/5, and then, so x.
Yeah.
So our a would be equal to 2/5.
Okay.
It's kind of sloppy, but yeah.
Okay. So we solved the x term. Now what about the constant term?
Because you're saying
Erase this
examples
part.
of how students
So in constant terms, we have
demonstrate
2 of
mastery
them
over time.
here. 10a plus a 25b
different ways, like, yeah.
equals this 7.
Yeah, so like what you said.
Okay.
Basically, like, through these portfolios, you could track that.
Okay, so I would switch that. Students
Oh.
demonstrate in no parentheses.
What's wrong?
There's an a and a b.
Okay. Do we know what a is?
Oh, that's right. Yeah, we do know what a is. That's one for a second, yeah. Okay, yeah. For a second, I thought this was a different a from that.
Street over time.
Okay, that makes
And the
sense.
next one too. What did it say?
This becomes,
Students
4,
monitor.
I think,
perform-
20
Oh, yeah, just
20 divided by 5?
Yep.
4?
If it's the how. How
25b
students
equals
monitor.
7. Subtract the
Or,
4,
right, or
we're
how
left
teachers
with
monitor
25b
students, or whatever you're trying to
equals
say.
3. So you divide by 25 and you get 3 over 25.
So like, what do you mean, like how do you?
Okay.
So now we have an A and a B.
Okay. So then what's our YP?
If we go back to what we started with, our YP originally was just AX plus B.
Yeah, teacher, right, teacher.
We know the values for both, so we can just write this as 5C equals C1 e to the negative 5x plus C2x e to the negative 5x plus the Y of P now, which has an A value of 2/5 x plus this constant that we just got. And then that should be our
solution.
Okay.
Okay. Let's try it. E to the negative 5x plus C2 x e to the negative 5x plus 2 over 5x plus 3 over 25?
Okay. That looks alright. Oh, what happened?
Okay, so something went wrong.
Let me see. Uh-oh.
Heck. That is not a positive 10. Therefore, our old answer was wrong. So we just went through and we made that negative, made that negative. That means these then become positive because these are negative. And so we change the signs on those, and that just means we have to change the algebra at the end. And so this is no longer a 3,
Yeah.
but this is
11.
11. And that looks good. And so now when we plug everything back in, it all looks good. And so it's important to double check your problem twice to make sure you're doing the same problem as the question you were given. And so that's about it. Wait, what section is this? Leading coefficients?
Yeah.
So what chapter is that?
This is chapter 4, section 5.
Chapter 4, section 5. So if you're struggling in chapter 4, section 5 of DE, Hector's got you. Come to Park, I got you. As long as we're doing the same problem that we were given, then we should get the right answer. But Hector did a good job today. You feel better about your test tomorrow?
I feel pretty good.
Okay.
I think I got it. I just
Alright.
have to pay attention to the problem.
Pay attention to the problem. Make sure you write it down, right? And then
I'm feeling okay.
Okay.
I'm ready.
all right. Well, I think that's gonna be about it for both of us. And good luck tomorrow. All right. So that'll be about it. And so yeah, if you see this, don't cringe. I'm sorry. And adios.